In most cases, the selected database type is driven by the type of data to be stored and the use case of that data. In that context, there are two main types of use cases in a typical organization: operational data and analytics data. Operational data is the data that is produced by the organization's day-by-day operation. It's pretty straightforward, and in most cases will look almost the same for many organizations. It can be data about the list of incoming orders, the up-to-date inventory status, list of customers, available products, open trouble ticket, information about employee working in that company, and more. Operational data is used to understand what's going on with the organization in real time. It should be up-to-date, real-time information. Operational activities are recorded in a database using something that are called transactions. Okay, a database transaction is a unit of work performed within the database. Think about a situation that a customer ordered some product. A new order should be created in the database, and the inventory status of that product should be updated. Those transactions are typically stored in the database as a simple two-dimensional structure, row by column format, like a worksheet in Excel. Transactions are typically handled by a system called oltp, online transactional processing. As an example, an ERP system, being used in many organizations that handles inventory data is an oltp system. This ERP system uses database optimized for oltp operation. Therefore, the database being used by this oltp application is considered to be also an oltp database, which means a database that can support transactions. In a typical organization, we'll find many oltp applications and therefore many oltp databases being used by those applications. Now, what is so special about a database transaction? Well, a database handling a transaction must follow something that is called the ACID model. ACID stands for atomic, consistent, isolation, and durable. An ACID-enabled database guarantees the full completion of a writing process to the database, which is extremely important for transactions. A transaction defines a set of actions that must be completed. There is no middle ground. The data in the database must move from state X to state Y. Let's use the same example of a customer that ordered some product. This action is creating transaction that must update the inventory status stored in the database. If the system is getting a new order and for some reason the inventory status is not updated by the previous transaction, then we have an inconsistency problem. The next customer will be able to order the same product even though the inventory is not up to date. Let's use another example, maybe more tangible example. If I go to an ATM and withdraw some money, the ATM system must guarantee the end-to-end process. If I got the money, then my bank account must be updated. If I didn't get the money, then it should not be updated. The consistency of transactions in an oltp database is critical. When a database complies with such an ACID model, then such problems are prevented. Another thing that characterizes an oltp system is the number of transactions. Those transactions can create a high volume on the database when added, updated, or deleted. Just think about how many people are using their credit cards in 1 hour. It can be millions of transactions, and everything should be recorded without mistakes in real time. Secondly, the expectation from applications using this operational data is low latency, meaning fast access to the stored data. If I'm looking for available tickets on a flight while using some website, I will not wait 10 minutes to understand which seats are available. The web application presenting this kind of information should get the data from the database system in seconds. If I'm standing in front of an ATM and checking my account balance, it should be performed in seconds. Performance is a key consideration in oltp system, and in most cases, the databases are the main bottleneck for those systems. Third, such operational data can be changed frequently with updated transactions. It is not just about adding more data to the database, it is also about updating the data already stored inside. Think about the inventory information of a retail store. It is updated in a high frequently intervals when getting new orders. This is the first type of data, operational data. This data is usually processed by oltp systems and stored in oltp-oriented databases. Another very important type of data is called analytics data, and let's talk about it in the next lecture.